Okay, there's one more subtlety I want to talk about. This is in this example, just to try to capture all the different types of things that can happen. One thing we haven't talked about is the situation where, say, you're headed from Thorn to Searles and you decide you need to turn around. You left something in Thorn or something. You run back. So in terms of our like picture that we've been having, you could have something like following, right? So here's our 5-minute mark. So something like this, I sort of mentioned this before, where it's like, okay, you leave Thorn at a certain speed, you realize all of a sudden, oh no, I left something, I need to turn around, and then you head back, and then you go heading off to Searles. And so in this case, there's something sort of interesting going on here. So down here, the velocity is negative, right? Down in this part of the graph, the velocity is negative, which is representing going back towards Thorn. Let me just write some of that down. So what happens if you backtrack? So negative velocity. In particular, what I mean is what happens with measuring distance, because we've said the area under the curve equals the distance traveled, but now we've got, well, we have this area, but then we have this area down here at the underneath. And it's like, what does this represent? Because this is, there's negative velocity down here. Negative velocity. So that means this area should really represent a negative distance traveled, right? If you want to think about it, the horizontal, if you just think about like maybe like a little box in here that you're trying to think about an area, right? Like the horizontal part of the box is positive number, but then the vertical is a negative number, because it's really like, you're really going, or maybe I really should, probably should just be drawing it up here. You're really thinking of this as a negative height, or a negative, it's negative velocity. And so you're multiplying a negative times a positive. Time is always positive. Time always moves in one direction. We can't control that. But since velocity could be positive or negative, we're sort of multiplying. So I guess what I'm trying to say is the area is a negative times a positive. Which is a negative. Right? And so, in fact, if you really wanted to think about this, let's just give these areas names, right? So let's just say this one is area 1. This is area 2. And this is area 3. All as positive numbers, right? So I'm saying A1, A2, A3. If we just think about the classic sense of area, we don't think about negative areas really. But so let's just think about these as positive areas. Well, there's two possible things. There's two things going on here, right? There's the total distance you walked, which, because you backtracked, is not the same thing as the total distance from Thorn to Searles. So what is the total distance walked? Let me just move down here a little bit. The total distance walked. Well, all of these areas represent distances. It's just, for this area and this area, you're going towards Searles, and for this area, you're going away from Searles. And so the total distance walked is actually equal to A1 plus A2 plus A3, right? But that's not equal to the distance from Thorn to Searles. And by the way, one subtlety I should say is you only here you're going down here, you're going to negative, you're going back towards Thorn, but only if these areas are equal do you actually make it back to Thorn, right? Because like positive, and then you go back for the same amount. So maybe you left your keys or something, and then or your one card, and you leave, and then you realize you left it, you turn around, you head back, and then someone part way back, you run into somebody who grabbed your one card, saw that you left it and grabbed it, and then they give it to you. So this could be something like, this doesn't mean you went all the way back from Thorn to Searles, but I mean, from Thorn all the way back to Thorn as you're, I'm just imagining scenarios here, right? So what is the distance from Thorn to Searles? Well, if you think about what A2 is, it's the backtracking, right? A2 is the backtracking you did. So you're actually going to subtract that from A1. That's why I'm saying if they were equal, you would actually get 0 there, but I'm not necessarily saying they're equal. So you get A1 minus A2 plus A3, right? So really, this is where you're taking into account the sign of the area. So this right here is like a signed area. It's like a negative area representing a negative distance. And that cancels out the positive distance that you walked. And so you really want that to be negative. So anything below the x-axis, below the horizontal axis should be considered negative and undoes. And so really, if you think about the distance from Thorn to Searles, that's a change in location, a change in position. This is a change. This is sort of a change in location, change in position, change in location. So that's where I'm saying change in position on the one hand is different from the total distance walked. So these are not the same as. And just as an example, so like, so you can imagine scenarios like this. I think that kind of gets at what I'm trying to get at, but let me just do a quick example. What if we said, what if your velocity function, in the previous example, we had something like 60 plus 80t. Let me do a different one. Let me say it's 600 minus 150t. Okay, so that's just a function. But if we graph that, if we graph velocity versus time now, well, we're going to have a function that starts up here at height 600. So you go rocketing out of Thorn pretty fast. And then if you think about when you get to t equals 5, this is actually, if you plug in right here, 5, you get 600 minus, that turns out to be 750. You actually get negative 150. So in fact, you end up below, you end up down here somewhere. I really should like extend the axis here. And so that is at height negative 150. And so now you have these two data points, and then you have the straight line connecting them. I'll give you a straight line. It's pretty close to straight, but okay, there's a straight line. So that's a straight line connecting them. And so now you have this interesting situation where it's like, okay, now what's the distance? First off, what could happen here? So what it means is, I imagine this as like you went past Searles, like maybe you just lost your train of thought. You actually you're walking, you pass Searles, you slow down, come to a stop, realize you went too far. So that's like, from here, you're walking, you're slowing down, you come to a stop, and you're like, oh crap, I went too far, let me turn around and go back. Okay, so that's, because the velocity is, 0 right there. So you actually come to a stop and turn around. All right, so now what is the distance? Well, the distance is, if we want the total distance walked, right, that would be the sum of these two areas, the area of this triangle and the area of this triangle. So that would be your total distance traveled. But if you wanted the actual distance from Thorn to Searles, which is like a change in position, a change in, change in location. So the, the distance now, so the distance from Thorn to Searles in this example is, it's basically, well, let me just give these names again. This is like, it's like A1, and this area is A2, then it's A1 minus A2, right? Because you're backtracking. By the way, this happens, you can check when does velocity equals 0 happen. It actually happens at t equals 4, because if you plug in 4 right here, you get 150 times 4 is 600. So right, so we can actually figure that out, figure out what this is now. The first area is 1/2 the base times the height of 600. And then we do minus 1/2 the base of the second triangle. The second triangle just has base 1, right? From 4 seconds to 5 seconds, right there. So that's 1 times, and then it was 150. In some ways, you could just think of the negative sign as being like really going right there if you wanted to, as the negative height. But you sort of think about it either way. You just have to be careful. We're just so normally we're so used to thinking of areas as positive that I'm sort of writing it down this way. But so that equals, you get 1200 there, 2400, half of 2400 minus, and then this is just 75, half of 150. And so it's 1,125 feet. Okay, so that is the distance from Thorn to Searles, but the total distance walked is 1200 plus 75, right? So minus 75. So that's 1275 feet. Okay, so hopefully that makes sense, but that's going to come up a lot whenever we're doing these areas under curves. We're always going to consider when the curve drops below the x-axis, we're going to consider those to be negative areas, and that's going to be important. I mean, usually it has an interpretation, and like here, it's actually, you can see that there's a real world interpretation that makes sense, and why you would want to consider that area to be negative. Okay, I'll stop.